Hello class, today we're going to talk about topic 8-5 for Algebra 2. These are the notes for 8-5, and we're going to be talking about exponential and logarithmic parent functions. So let's start with an exponential function. This is 2 to the x. Anytime you have an exponential function, x is in the exponent. Well, let's go ahead and figure out what these values are. Well, 2 to the negative first power is 1/2. 2 to the 0th power is 1. 2 to the first is 2. 2 squared is 4. And 2 cubed is 8. Let's just go and graph this. Negative 1 would be at 1/2. 0 would be at 1. 1 would be at 2. 2 would be at 1, 2, 3, 4. And 3 would be at 8. 1, 2, 3, 4, 5, 6, 7, 8. Now when we graph this, it's very important that this hugs 0 for swinging up and hitting our points. So we actually have an asymptote at y equals 0. Now, for our domain, we go forever to the left, we're going to go forever right. It's all real numbers. But for our range, while we go forever up, we stop. We come to a stopping point. We never hit 0. And because we never hit it, we cannot say equal to. We must say just simply that y is greater than 0. So that is a parent version of the exponential function, 2 to the x. Let's go ahead and talk about logarithms. Well, these are the inverse functions. So it's going to be the other one turned sideways. And let's see what we get. Well, log base 2 of x. So log base 2 of 8 would be 3. Then 2, 1, 0, and negative 1. I want you to just kind of notice that here, all we did was we flipped these two columns. That's what logarithms are. They are the inverse of exponents. So let's see what this one looks like when it's graphed. If I have 1/2, I'm at negative 1. I'm at 1, I'm at 0. If I'm at 2, I'm at 1. If I'm at 4, 1, 2, 3, 4, I'm at 2. And if I'm at 8, I'm at 3. And this one is going to swoop in from negative infinity, hit our points, and then start shooting out. Well, we've got our asymptote. Our asymptote here lies along the x-axis. So x equals 0 is our asymptote. So our domain, x must be greater than 0. And our range, we go forever down to forever up, all real numbers. So these are our two parent functions. Let's go ahead and see what happens when we start to transform them. So I want you to kind of notice that they've got the 2 to the x in parentheses, because this 2 is our base, and it doesn't affect how our graph goes as far as transformations happen. This 2 right here, this is the a value. Okay? And our x minus h, that's all going to be in the exponent. K is going to be the outside. So 2 is going to stretch by 2. And the 1 is going to move up by 1. Let's go ahead and figure out what we have. So, we copy down our numbers from up top. 1/2, 1, 2, 4, 8. Starting at -1, 1/2. We're going to multiply that by 2. Well, 1/2 times 2 is 1. And then we're going to move up by 1. 0, 1 times 2 is 2. Moving up 1 makes it 3. 1, 2 times 2 is 4. Up 1 makes it 5. Hold on. 0, 1 times 2 is 2. Up 1. Thought something was looking off. I moved up too much here. So this point is actually at 3, not at 4. So that this point can be at 5. And then 3, 8. 1, 2, 3 to 8. Well, multiplying that by 2 makes it too big to fit on the graph. So we can only put these 3 points. Now we have to figure out our asymptote. Well, our asymptote moved up by 1. So our asymptote, no longer at 0. Our asymptote is at 1. So y equals 1. So our domain of all real numbers, because we hug this, swoop up and get very steep very quickly. And our range is that y has to be greater than 1. Moving on to number 4. Another exponential. 1/2, 1, 2, 4, 8. This time we are flipping. We are moving left 3 and down 5. So, -1, 1/2. We flip it to be -1/2. Move left 3 and down 5 more. So 1, 2, 3, 4, 5. 0, 1 we flip, then move down 5 more. Left 3. 1, 2, 3, down 5. 1, 2, 3, 4, 5. 1, 2, flip, becomes -2, left 3, down 5. 2, 4, flips to -4, left 3, down 5. And you can probably already tell that we've run out of space for our next one. Well, our asymptote also moves down 5. So we draw our line. Our asymptote is at y equals -5. Our domain is all real numbers because we go forever right and left, but our range is that y must be less than, this time, -5 because we are below the line. So that's some practice with exponential graphs. Let's go ahead and work on our logarithmic ones. Again, it's going to be y equals a times log base 2 of x minus h plus k. So the minus sign flips us. The minus 1 moves right by 1, and the plus 2 moves up by 2. Fill in our numbers. We have negative 1, 0, 1, 2, and 3. Our domain, well, let's figure these out here in a little bit. We start at 1 half negative 1, and then we flip to positive 1, move right by 1, and up by 2. Then 1, 0, we flip so it stays there, move right 1, up 2. 2, 1, we flip to negative 1, right 1, up 2. 4, 1, 2, 3, 4, 2, but flip to negative 2, up 1. And then 8, 3, we flip to negative 3, I forgot to go right 1 and up 2. This one needs to be here. I forgot about my right 1. And now we need to figure out our asymptote. Well, on these, our asymptote is an x equals line, so we need to move right 1. So our asymptote here is at 1, which means we hug the asymptote. And our line goes out there. So our asymptote is at x equals 1, which means our range is that x has to be greater than 1, and our range is all real numbers. Moving on to number 6. We fill these out, negative 1, 0, 1, 2, and 3. We stretch 2 and up 3. So 1 half negative 1 times 2 makes it negative 2, up 3. 1, 2, 3. 1, 0 times 2 is still 0, up 3. Our 2, 1 times 2 makes it 2, up 3. And I put that first dot in the wrong spot this time. I didn't move up 3, I only moved up 2. 1, 2, 3. So that was 2, 1, 4, 2. 1, 2, 3, 4, 2. Times 2 makes it 4. Up 3. And 8, 3. 1, 2, 3, 4, 5, 6, 7, 8. 3 times 2 is 6. Plus 3. And if you'll notice, This time we didn't move any right or left, so our asymptote remains at 0. So x equals 0, which means that x has to be greater than 0, and our range is all real numbers. On to sentences. Well, we know we're going to start with f of x. And we know we're going to have log base 2 of something. We're moving left 3, so that's plus 3, up 2, plus 2. For exponential, f of x equals, we know we're going to have 2 to the x power. Left 1 means plus 1. Down 7 means minus 7. And shrink by 0.5 means that we put 0.5 in front. Last sentence, start with log 2. Reflect across the x-axis, stretch by a factor of 5. And that's all that we're doing. So, again, the sentences are pretty easy. Let's see what we can do about the graphs. So first off, we need to identify, is this a logarithmic or is this exponential? So we got to figure out where our asymptote is. Where our asymptote is where it's hugging the line. It's hugging the line here. And because it hugs the line going vertically, we know that it is a log function. Okay. Well, right and left we didn't move, so we know that that's just x. Now we got to figure out where up and down is. To figure out where up and down is, we have to figure out where our first point is. Our first point is here. It's wherever it crosses at 1, which was moved up by 3, so plus 3. And if you'll notice, it's going down, so that means that this is negative. Let's go ahead and move on to number 11. We find our asymptote is horizontal, which means that this is an exponential. So 2 to the x. We got to find our first point. We can tell that it's moved right by 1, 2, 3. So minus 3. And from our asymptote, we know that it's moved down 3. So minus 3. And it's still going up, so we are done. Take a look at number 12. Horizontal asymptote means exponential equation. We know that we've moved up 1, 2, 3, 4, 5. We look at our first point. It appears we've moved left by 2. And it's going down instead of up, which means that we need to make it negative. And last problem. Our asymptote falls here. Our first point is there. This is a logarithmic function. Where we've moved left 6, so x plus 6. We've moved down, no, we've moved left 7, because that's where asymptote is. We moved down 1, I moved down 2, 1, 2. We're still going up so that we know it is positive. So, this was the notes for 8-5. Good luck on the assignment. Have a good day.